Hello, everyone. Welcome to the Political Act of Seed Keeping with Rhianna Simes. I'm Jenny Chamberlain with Beaverton City Library. This event is part of the library's community-wide reading program, One Book, One Beaverton, which this year is in celebration of the novel The Seed Keeper by Diane Wilson, which probably most of you know this by now. Please be aware that we will be recording this presentation and posting the link on the library's website in the weeks following the event. If you have any questions for our presenter, please submit them in the chat as they occur to you. She will answer as many of your questions as there is time for at the end. Okay, I want to introduce our presenter tonight. Rhianna Simes recently retired from 10 years as an instructor at the Oregon State University Extension Service, where she developed the Land Steward program and also coordinated the Master Gardener program. Rhianna earned a Master's of Science in Education and Botany from Southern Oregon University in Ashland. Rhianna lives with her husband and 2 young children outside Talent, Oregon, where they operate their own certified organic farm called Verdant Phoenix Farm and Nursery, which specializes in organic plant starts, basketry willow, perennial food, healthy soil, and natural farming. Rhianna also serves on the board of directors for the Southern Oregon Seed Growers Association, the Rogue Valley Heritage Grains Project, and is the current co-director for Cultivate Oregon. All right, and now I'm going to turn it over to Rhianna.
Great. Bienvenidos. Welcome. I'm gonna get my slides ready here. Okay. Okay, welcome. Thank you so much. I feel like I'm with my people tonight to be here on a dark, wet Oregon evening to talk about seeds. And so thank you for being here. And you know, I really invite as many folks feel comfortable to turn on their videos so that we can see each other and at least laugh together or interact. It's so much more fun when we can have a bit of even just discourse through our nonverbal. And so thanks for being brave to turn on your video if you feel comfortable. So, you know, I want to just share specifically that I am not Lakota. I am connected to a local Lakota elder, Eddie Little Crow, and so I really want to acknowledge him this evening. I'm not a geneticist, and so I'm not going to do a deep dive into genes and chromosomes, and that's not my area of expertise. And I am also not unbiased. I have an opinion, and these are my opinions based on research and based on my experience and education. I am an adult educator, and my goal is to inspire you. That when we fall in love with something, we can't help but change our behavior and value something differently. And that's really part of my intention tonight. I want to weave in some of the amazing lessons from The Seed Keeper that all of you read. But really, I'm an advocate. I'm a trained botanist. I'm an avid gardener and seed steward, and I'm a certified organic farmer. And so it's really from that lens that I'm excited to share this amazing talk. It's really a talk that's been brewing in my life for years, honestly. And that's because, as I mentioned, that I have 10 years experience working at OSU Extension Service, and that it was always very hard to not get into the politics of seeds, even while teaching botany or gardening, because it's really inundated and part of the agricultural system that was created in the United States and on purpose, with intention, the way that it was created. So my background, we have a 10-acre certified organic farm and a certified organic commercial greenhouse. We have several USDA-funded research projects on soil health and strategies to terminate plants without tillage or herbicide. I've been working with the Organic Farming Research Foundation around how to reduce herbicides in agricultural lands, and I'm part of the Southern Oregon Seed Growers Association. I also help to coordinate Cultivate Oregon, where we empower responsible food and farming. And part of our work is to support local seed swaps. And whenever we have a seed event or begin a seed swap, we always really appreciate starting with some kind of intentional land acknowledgement, to really acknowledge, to take an intentional moment to acknowledge, the elders and the work that have gone before us. I want to acknowledge my teachers, Rowan White, Don Tipping, Masanobu Fukuoka, who all believed in planting seeds and the power of seeds. And as Rowan White talked about, that we're really acknowledging seeds as our elders and our children, that the indigenous everywhere have worked to care and tend for seeds. And we're really benefiting from this history and this work and this love, and those generations who are still here working the land, and from wherever we come from and from wherever we are. I just want to start with a little bit of intention, because we are blending, as Diane Wilson did, we're blending culture and belief and science, and we're blending it just as we blend it in our own lives. So for folks who weren't able to participate in the One Book, One Beaverton, the reading of this Seed Keeper by Diane Wilson is really this, I love this beautiful story and reawakening of this original relationship of seeds and to our ancestors, wherever we come from. And that really drawing this sharp contrast with the modern industrial farming and the damage that it's doing on the earth, the damage it's done to seeds, and the damage it's doing to people and to our bodies. So this dance of life and really the role of seeds and preserving identity is really at the heart of what we're talking about tonight, in the heart of this novel. So I just want to really appreciate each of you for taking time to read this book and to think about these concepts deeply, and to show up tonight in the class to kind of go deeper about seeds and genetically modified organisms, or GMOs, and why this matters and why we should care, what this means. And so we might leave with more questions than answers, but we just want, as Grandma Agnes Pilgrim, who's a Lakota elder here, she really talked about taking that longest journey from our head to our heart. And that's part of what we want to do tonight, is to engage our heads with this work, with some crunchy science, but really to engage our hearts as well. Of why should we care about this? Why does it matter? Just seeds, they're so simple, and yet everything starts with them. And so that's part of what we're here tonight for. Because food is culture, and culture is part of food. And so that cultural identity that comes from our food is really the place that I'd like to start tonight, to really help awaken your hearts because it's kind of a contrast, right? To dip into heavy science and to awaken our hearts. So already we're kind of on uncharted territory that Diane Wilson has helped us to find. So I want to make this personal. I'd really like for each of you to just take a moment to think of a family dish, a family food dish that means something to you. Like, what's something that you make around the holiday or a special event that, the event wouldn't be the same unless you had that food to help mark it. And if you want to, if you feel like sharing, I'd love to see in the chat what's coming up for you. If it's a special corn that you make your tamales in winter time for Christmas, or like the pink watermelon with black seeds at a summer picnic. That these foods have meaning, and they create identity to who we are in our families, and how we pass down information and traditions to our children. So thanks for folks who are willing to share. Love that summer strawberry freezer jam, those sweet strawberries. Pumpkin pie, yes. But so much culture is woven into our food. And so this is why seeds matter, is because food helps to identify and to shape who we are. Oh, yum, homemade noodles. That sounds amazing. So food is culture, habit, craving. Food is identity. And food, of course, starts with seeds. So, as a botanist, I can't help it. I have to start with some botany of where seeds come from. And I love this quote from Diane Wilson: "History might have cost me my family, my language, but I was reclaiming a relationship with the earth, the water, the stars, and seeds that was thousands of years old." That's true for all of us, wherever we come from. So we got to dive into a little bit of a geeky botany moment to make sure that we can all speak the same language. So parts of a flower, and if you want to brag and you already know some of this, you can put it in the chat. I love teaching botany. And this is where the class always gets a little racy, and we're like suddenly talking about sex for the library, and they're going to understand that this is part of, in a critical part of botany. So the important parts here, the male part of the flower, some flowers have both parts, male and female. The male parts are the stamen. That's the anther and the filament. So in the stamen produces the pollen. And that's important because that's what moves around. That's the genetic material that moves around. Then there's this the female part of the flower, which you can see the stigma, the pistil there, the stigma at the top, the style, and the ovary. So that is the female part of the flower. And then we could totally geek out on the other parts, and I would really want to. But really what we are caring about right now is really how fertilization works and what happens. Let's see if I can advance my slide. It's so funny when, there we go. Okay, so what happens, and it's funny because in botany, they barely cover this when I was doing my master's, and it seems really important. So I'm going to talk to you, and folks who want to know more can also read if you want. But part of what happens is that this pollen grain is dispersed either by insects or wind or birds. The pollen moves around, and that pollen grain lands on that stigma, the very top of that female flower. And what happens is that then these acids are interacting, and this pollen tube, this whole new creature, develops all these cells, this one pollen grain, and it makes this pollen tube that actually travels down the female part of the flower and then delivers the genetic material there to the ovule. So this is really amazing, that this can happen, and that it happens all the time, and that pollen has found all of these ways to move around. And so this is where seeds come from, is that then that genetic material, part of that raw material to make genetics, part of it becomes the food for the seed, and part of it becomes the actual genetic being, the embryo of the seed that has everything it needs, that self-contained nutrition source to then create a seed. Here's another way. Oh, this is a little blurry. Sorry. Here's another version of the same image where you can just see that it is miraculous and amazing that these pollen grains are blowing or finding their way on the bee, and that then it creates this amazing appendage and interaction that then genetic deposits its materials. And then you can see the developing seed. How amazing to be formed with just enough food to help you until you can create your own through photosynthesis. Wow. I was really lucky to have botany professors who still really encouraged us to maintain the sense of awe and wonder of botany, that even if we have words to describe something, that we can still be in awe of, wow, these parts that we don't even still understand exactly what happens and when, but we have words to talk about it. So of course, that's what is in a seed. So of course, seeds serve as the vehicle to reproduce and spread their genetic material. They come in all shapes and sizes and have different strategies for moving themselves around. So seeds are, part of the strategy is that you've got one plant, you got to find a way to get your babies to more land, more resources, more opportunity. So how are you going to do that? But it's really in this ability to postpone germination that's really amazing. And that's unique to all other creatures, right? Is that usually when all of that genetic material lines up, then there is this gestation stage. But really it's this postponement of germination and breaking dormancy until things are just right, till there's enough water, there's enough temperature to then trigger that domino effect of germination. So let's talk a little bit about types of seeds and where seeds come from. So what we're describing was open pollinated seeds. And so these seeds are from the result of natural pollination and often lead to this genetic diversity in the plant species that is really important. The more diversity, the better. That's part of the fundamental value, I feel like, in plants. So hybrids are then produced by crossbreeding two different species, resulting in specific desirable traits. So that way that hybrids often have more uniformity and vigor. They are not GMOs. So these are non-GMO seeds, open pollinated, which means that insects and creatures have moved that pollen around to that stigma, that's all happened naturally and occurred as it had for millennia. Hybrid seeds, that is more of a breeding technique in order to get the same type of plant each time. So we're talking about open pollinated. That's what I was just describing to you, this magic and wonder that happens with pollination, that this diversity and this impossible moment of creation and life. Hybrids, heirloom is another great way to understand and value seeds, are heirloom seeds. And so those are open pollinated seeds that have been saved for 50 years or more. So heirloom means it's a cared for variety for many years. And then part of what we're going to talk about tonight are GMOs. That's a shorthand way to talk about genetically modified organisms. These are plants that were created in a lab, and they're created by modifying DNA. So this is insects have nothing to do with it. Nature has nothing to do with it. These are highly sterile lab environments with petri dishes and splicing going on. So this, I really want to juxtapose the open pollinated opportunity to help mix diversity, help bring in other traits, help nature really determine the best traits for the ecosystem, for the environment where they're growing. So heirlooms are often then types of seeds that have been selected over time by people saying, this is a great pumpkin, it gets really big. This is the type of wheat you want to use to make your homemade noodles. This is the type of watermelon that's pink and has black seeds. I'm going to save these seeds and then replant them and save them, each time selecting for those characteristics that are for people's benefit, generally, or animals, but mostly for people's benefit. So the benefit for people, that could be nutrition, that could be pest resistance, disease resistance, flavor, productivity. Those would be reasons that people would select seeds and what would become an heirloom variety. So part of the important piece here with heirlooms, and to understand in this, bigger conversation about seeds, and we're building momentum, right? We're getting this context of we're getting this science out of the way so that you really can have a deeper understanding and appreciation of what goes into local seed breeding, what goes into locally adapted seeds. So this is an incredible mechanism in evolutionary biology where the organism retains information about the environment where it's grown. It means that the plants actually are retaining information about the soil that they're growing in, what nutrients are there or not there, the pests that are around in that environment, how they're being watered, and what maybe the amount of sun or climate wise, like how cold are the winters. So locally adapted means that those seeds have that information of where that plant has been growing. So then when you plant that seed, so you grow your tomato, let's say it's in your garden, boy, it did really well for you. And then you save those seeds and you plant it again. That seed, that plant learned all of that information and has that information to grow well in your location in that seed. So then we plant it again, and wow, our tomatoes do even that much better because they have all that background information. I'm saying information, but that's, in plant ways. So what I see often is when people are like, wow, my tomatoes did amazing. I'm going to eat them. And then the next year comes along and I'm going to buy seeds that I see online that are grown in Canada or China. Huh. Are those seeds going to grow as well in your location as something that's been grown across the world? No. So local adaptation is part of what we're breeding for, what we're encouraging for locally adapted seeds. That's part of what you get in an heirloom and why they're so special is that people have said, wow, this tomato needs less water and still yields. This tomato doesn't get blossom end rot. This tomato tastes delicious. I'm going to save this, pass it down. I'm going to bring it with me when I, share my abundance with other people who live around me. It's a big deal. So as the plant grows, like we just said, it is retaining information, even relationships with soil biology. They're finding that these creatures, mycorrhiza and other soil food web creatures have these relationships, and that information is, those connections and that connectivity is also one of the part of what the plant retains in local adaptation. And so each year the information is stored more and more, that the seed carries on this knowledge of the past. And so this is where the metaphor starts to become so deep of what it means to care for seeds in a place for a food that has meaning in your culture or makes you part of who you are. That's the depth of what we're talking about, that it has both physical science implications, but this cultural thread that Diane Wilson wove through about what's lost, about what's gained, what is worth carrying forward in these dishes and these plants that we grow. So I'd love to hear from you in the chat. Why does it matter if seeds are locally adapted? I assume you're all gardeners or plant lovers, seed lovers of some kind. Yeah, why does it matter? Do you think you should buy locally adapted seeds? What would that do for you? This is an education piece. This is an important piece. This is that where we're starting with the call to action piece. Because what does it matter if we plant seeds grown in China? Not to pick on China, or like Slovakia or Mongolia. What does that matter? I'd love to put it in the chat. Part of how it matters is, especially so to bring it down a little bit more, on the, if you buy from seed companies on the East Coast, the East plants growing on the East Coast are used to summer rain. We don't have summer rain in Oregon, at least in Southern Oregon, we got nothing. So already the plants have a different expectation. They've been raised for generations with a different understanding of what, even if you have irrigation, but they have that knowledge and kind of preparation for summer rain. Whereas we here in Oregon are really needing more and more drought tolerant, resilient varieties. Yeah, they might not do well here. And yeah, having that sense of home. I love that. So we're talking about these different types of seeds: open pollinated, hybrid, heirloom. And now I really want to shift to talking about genetically modified organisms, or GMOs. So these are, again, seeds that come from labs. That's now what we're shifting into. And some of this is so heady. I have to like provide some research and some like peer review information, but it's pretty dry. But I wanted you to have it just because it's important to get the words right. So the piece that's important here is that genetically modified organisms, that their genetic makeup is artificially modified or altered. Individual genes are introduced from one organism to another organism across species. So we're not talking about breeding tomato tomato. We're talking about taking genes out of pigs and splicing them in, or I guess it's actually flounder fish, and splicing it into tomato genes in a lab. So not tomato tomato, we're talking about fish tomato. And so this is part of where, I'm going to give you the science and the information, but there's also a deeper, really some deep fundamental questions about our role in working with plants and our role in the ecosystem. And if, it starts to become, is this appropriate? Is this the right thing to be spending time and money on? Let's dive into it. Let's really look at this and really see, because right now the safety of GMOs is unknown because of the lack of independent research around it. So here's another way to talk about this. So GMOs had DNA artificially altered in a laboratory from genes from plants, animals, viruses, or bacteria in order to produce those foreign compounds in that food. So in corn, they're splicing in Bacillus thuringiensis, a bacteria that attacks a worm. And so they're splicing in a virus into that corn. So this is, again, not a natural process. These are not natural systems. So in understanding, again, this is the part where just honestly, it's a bit over my head. And you can go really deep into any of these very, very creepy sciences. And it's very heady to understand. And so I'm not going to go into all of this piece, but what I do want to add is that part of what in the education and outreach materials that are put out from industries around GMOs is they always make it a bit confusing. See how in this poster even it looks confusing about, well, what do you mean? Why is traditional breeding listed under genetically modified? Traditional breeding, crossing plants and selecting offspring, and it's all in red and almost all crops, and it is completely confusing that is the natural way of crossing plants, of traditional breeding. But it makes it seem like, oh yeah, this is the same as mutagensis. It's just all listed right here. So there's this intentional effort to confuse the issue and confuse the difference between what happens in nature and what happens in a lab and would never occur in nature. I wonder why they would want that to be confusing. Why would they want that to be confusing and for people to not really understand which is which? The red is all like, oh, look at those genes. That looks dangerous, right? And then you have like, oh no, it's just the cereal grains and RNA interference. Okay. So what are they even working on? Well, the creepy part is that they're working on the biggest commodities that are in all of our food. That is the really super creepy, honest part, is that the GMO alfalfa, wheat, sugar beets have often taken over many of the sugar sources, cotton, soy, and corn being one of the biggest. This is where, I think that kind of up until now, probably some of you are like, I don't know, this seems kind of fringe. Like I've never heard of anybody growing GMOs, or like, does this really actually happen that much? More so, think about everything that corn is in or corn syrup is in now. And when you think about that, more than 70% of corn grown in the US has been genetically engineered. 70%? That's when the reality should kick in of, oh, this is actually everywhere. And we need to understand the difference, and we need to understand why it's a big deal. Some of these, the papaya, the peas are not really in the market. The summer squash are not really in the market. Soy is the other one. You know, it's a little soy milk in your coffee in the morning, or just a little tofu here and there. And then you think about more than 93% of soybeans in the US are genetically modified. So that means almost everything. So if your special cultural dish, if your special dish involves edamame or any kind of soy product, oh my gosh, what a contamination that's happened. So common foods that have GMOs, really the most commonly packaged foods, are made from sugar, corn, soy, and canola. Canola oil being some of the most major, and really seeing these differences of US. And this is where I'm not making this up. This isn't because I'm unbiased. This is the information that the universities are putting out about what they're proud of what they're using. They're not generally often trying to hide it. They're actually saying, oh no, we're putting it in children's cereal, we're putting it in formula, we're putting it everywhere, and wanting us to be really excited about it. So the information is out there. So here's another example of what you find. Purdue University, you're like, well, gosh, what are GMOs? Help me understand this. And then here's another time where it becomes all confusing. Well, humans have crossbred plants for centuries. Developing genetically modified organisms is a more targeted process. It's like, well, if those aren't two confusing, misleading sentences that distort the conversation and distort what we're actually talking about, which is, are we talking about plants that are bred in a natural system that come from nature, or are we talking about plants that were born in labs? And many people in Oregon just said, you know what, I just want to have the right to know which one it is. Maybe there's people, they really want to grow that and eat that. I just want to know, is it in my food? Is it in the food I'm feeding my children? We don't often know. So why do we care about GMOs? This was always so important to me when I worked at OSU, was to be like, why do we care? What are we going to do with this? So why do we care about GMOs? We're going to get into some more reasons, but part of the reasons is that there's no local adaptation in the seeds. The seeds aren't, the plants that are being grown in those seeds are licensed, and farmers have to create a license, and they plant that seed 1 year, and then they have to buy the seed again and replant that seed. So they cannot save seed from GMO plants. It's illegal, and it's in their contract. So there's no local adaptation. They're even preventing local adaptation. So if we care about local adaptation, that might be a big deal. Seed companies have been consolidated by chemical companies. So we're going to talk about that more. We're going to talk about the increased use of pesticides. Crops like Roundup Ready alfalfa that are genetically modified in order for them to be sprayed by Roundup and still survive, so that you can feed it to animals and then eat that meat. So part about why we should care about GMOs is that these changes are unnatural, and they occur in a lab environment. And that's one of the pieces that, as you know, folks who come to a class about seeds and GMOs on a wintry night, you know, this is part of what I hope that you'll carry forward in an easy to understand way to communicate that difference coming up in the seed, you know, in the seed growing season, frankly, and to help our neighbors and our family members understand that difference. Even if you don't remember the plant part names or any of that, it just, well, one comes from a lab. So there's also this piece about why do we care about GMOs is this question of control and ownership of living beings. Should life be able to be patented so that a company can say, I own this life here? Is that okay? And then the other reason we care about it is because it's been shown that the GMOs move around, that there is this contamination of with non-GMO plants, and that for certified organic farmers who are not using chemical pesticides, if they have to go through a screening process to test, are there any GMOs? And if there are, they cannot sell their seed or their product. And actually what has happened in around the country, in different parts of the country, is that sometimes when they test their seed and if GMO contamination is found, farmers have been sued because the chemical companies are saying, you infringed on our copyright and now you have to pay me royalties. Wheat blowing out of the back of trucks in Montana, cross-contaminated farmers' wheat fields, and they lost their farms because of this copyright patent infringement. This is real. This is in the Northwest. This is in our lifetime. One of the most important reasons that I think you should care about GMOs is that 80% of GMO crops have been grown and engineered for herbicide tolerance. So I want to be clear because there's this myth that GMOs will feed the world and that GMOs will help end poverty and these myths. But what is real is that the seeds that they're that the plants that they're modifying are not being selected for nutrition, for yield, for health, for any benefits to the farmer. It's for pesticide or herbicide resistance. So that's really important to sink in because these wealthy people go on TV and they're like, oh, well, we're going to save the world. We're going to help these other people to learn how to grow these crops, when actually it's really about selling herbicide or pesticide. So if you're not aware that, there are many dangers of pesticides that for humans, for the environment, for animals. So when folks are in Klamath Falls down here in Southern Oregon, folks were growing Roundup Ready alfalfa to feed to cows that they were selling beef from. And so they're spraying their fields, not one, but sometimes 2 or 3 times with herbicide. And they're not washing it off, right, before they feed it to animals, that it's just saturated, and then they feed it to animals. And then that becomes part of the food we eat. I think this is a great, way to really ask about this. Gosh, if it's not safe to breathe when you're applying it, should I really eat it or feed it to my children? That's a personal question that each person decides for themselves. So part of what is inspiring is that despite these challenges, that there is a resistance to GMOs, that it is a wave that has crested and fallen in some ways. That in Oregon, we had a Yes on 92 several years ago, which was to push to label GMOs in products available in the store. And it was really about that Oregonians, that we have a right to know what's in our food. And we have a right to know if those pesticides have been used or if something has been created in a lab that we wouldn't ordinarily expect to be in our food. So there has been a resistance, and there is a resistance in Vermont that they are now labeling GMO ingredients. And maybe you've seen, on the back of some of, snack foods that sometimes those ingredients are listed and hopefully can help you, make an educated decision about it. There are other countries who have banned GMOs that have, full out said, no, don't bring this in. We don't want it. And they are really leading the way in understanding the cultural heritage that is at risk and the kind of the opportunity for identity to be really dismantled by an onslaught of chemical companies selling seeds. There's a little history here, but this is where we start to see this really important moment with rice. You think about rice on the world stage as a commodity and crop that is contaminated by a GMO, and then costing farmers millions in losses. This is an important one. 2013 here in Oregon, a Roundup Ready wheat variety. So think about wheat growing in Eastern Oregon that's sprayed with Roundup to dry it before it's then hulled and made into flour. And so Roundup Ready wheat was found in Oregon after field trials ended 10 years earlier. So that means that those genetics, contaminated the wheat fields and were still kind of, causing contamination. And then you can see the wheat growers in Montana here. So this is a Northwest issue. This is an Oregon issue. Some of those consequences, you're hearing it, talking about genetic drift and what that is. We've mentioned about the increased pesticide application, this loss of biodiversity, which is one of the pieces we're talking about with the selection of seeds and why. And then the consequence of seed patents and owning life. So when you think about, I don't know, maybe is it a big deal if somebody owns a patent to a seed or owns, who would do that? And who is this? Who are these companies who are modifying organisms? Who are creating GMOs? These are huge chemical companies. Syngenta, BASF, Bayer. These are companies who are making money selling chemicals. Dow, DuPont. We know these guys, right? These are the guys who develop chemicals, but why would they want to own seed companies? What are some of the cultural implications of these chemical companies owning seed companies? Excuse me. So Monsanto is one that you need to understand. You've all heard of. Their best known product, Roundup, and then being bought out by Bayer. So two giant chemical companies now owning seed companies. And in 4 companies that were listed on the chemical, slide earlier, all seeds, they own 60% of all seeds and 70% of all soybeans, 80% of all corn. That means that the chemical companies have bought up, and we're not talking about varieties, we're talking about seed companies, any source of seeds that's being concentrated into the hands of chemical companies. This is a really downer part of the presentation. It's going to get better. We're moving through it. So what's the big deal with this? So genetic drift. So let's just say, wow, what can't one farmer just plant some GMOs over here and leave the rest of us alone? No, because of what we learned about pollen earlier is that pollen is moved around by wind, by insects, by animals, and that genetic drift happens between plants. People in Oregon, they like to say, has that ever been proven? Yes, it has been proven in wheat. We just saw the timeline with wheat in Montana, with wheat in Oregon. It has happened. This is a reality, and it is a real concern. And if organic farmers have GMOs in their crops are worthless. So these consequences of GMOs, we talked about the increased herbicide application, starting to cause super weeds and super pests, where now they used to just apply it maybe 1 time, and now it's starting to be 3 or 4 times. Between 1996 and 2011, herbicide use grew by 527 million pounds increase. And whose backs is it being sprayed on? Who's interacting with these sprayed plants, picking it, getting it on their clothing, coming back to their families after it? 11 billion in settlements. So this is where this isn't even political what I'm saying. This is just research and facts. 11 billion in settlements because it's unsafe and causes cancer. There's zero excuse now to use this product. Zero. The other piece that with the consequence of GMOs is really this loss of biodiversity. And as someone with Irish heritage, that this is really poignant. This is real, this is real life where folks depended on one variety of potato, this lumper potato. It was complete monoculture in the whole country. And then a blight spread and it decimated the population and people starved. And it was because of a loss of genetic diversity in our food supply. So 11 crops can be grown in the US, 11 GMO crops can be grown in the US, cotton, soy, corn, potato, sugar beets. These are, ones to really look out for in our food. So we're just kind of, again, we are going to get back to the resistance, but it's just important to understand really what's at stake in that these patents now. So we have chemical companies who are buying seed companies and then starting to say, you know what, I own this. I own these I own these seeds. I own these individual organisms because I got to the office first. And this is happening now. It is, you have to pay a royalty to use these patented plants. And as consumers, we can really choose to not buy them. So when we're shifting into these potential solutions, that Farm Aid really talks about to really look at this fair and affordable access to seeds, to increase these open pollinated breeding programs so that we can find ways to avoid the use of GMOs and the herbicides that they support. And really to hold these biotech companies accountable for the harm that they're doing and the loss of life and loss of biodiversity. So here's where we shift a little bit into the resistance to GMOs, that this is real and alive in Oregon, and we should take heart and be hopeful that this is a big deal and we need to understand it. And I'm so proud to share about the efforts in GMO-free Jackson County. That's where I live down here in Southern Oregon. And part of what happened is that a group of concerned farmers found sugar beets being grown in Central Point, and they said, oh my gosh, I have beets growing right down the way and have an organic contract. And so they created a ballot measure to ban the cultivation of GMO crops in Jackson County, Oregon. And it won by 66% of the vote. Nobody agrees on 66% for anything these days. And Jackson County voters said, oh, no, we don't want GMO crops in our county. It's going to ruin ruin the culture and the farming in our economy here. So Monsanto spent over $1 million fighting the effort and lost, and then tried to sue the county again and lost. So we feel really proud of this. And this is close to home because in Willamette, they are growing GMO canola there in the Willamette Valley. This is an issue in your neighborhood that you should potentially be concerned about. Canola oil is in so many products these days that right now in the Willamette Valley, the farmers were limited to 500 acres of GMO canola, and the chemical companies are pouring money into the Willamette Valley to say, we want to grow more than that. We want more acreage than that. And the specialty seed industry is saying, no, you cannot grow more than that. You're going to cripple the seed industry around the state because of the contamination issue, because GMO canola can cross with other brassicas, other mustards, other broccoli, things like that in the brassica family. So this is what's happening in the Willamette Valley, that they're saying that they're trying to expand from 500 acres into 2,500 acres. And so this is an opportunity, for folks in your area to tell Ken Helm what you think about that and why. And it's really because there's a lot at stake, and it's really up to us to protect the seeds of the future. And so what we can do, we can get involved in GMO issues. We can value local seeds, that as we're moving into the springtime and starting to look at seed catalogs and dream about our gardens, that we can really select from locally adapted, open pollinated seeds that were grown in nature. And if you feel mobilized around this issue with the GMO canola in the Willamette Valley, the Friends of Family Farmers are really taking a lead on that and have more information on their website. What heritage are we leaving for the future? And how can we participate in seed saving ourselves? When I taught the Master Gardener program, I worked with, hundreds of people every year through that program. And every single person could always remember the name of someone who took the time to share with them about plants, or took the time to share with them about seed saving. And so this is now a call to you, my friends, my seed relatives, is not only to practice saving your own seed, but to share that with someone else. And that, yes, there's some nuance as you get deeper into seed saving, but really it's just select the plants you want to save seeds from, harvest them when they're dry, make sure they're really dry, package and label them in something that works for you. There's all kind of containers that you can find online. Make sure you put the name, the year, and I really always like to include that why you chose those seeds or those plants. Were they the ones that bloomed early or bloomed late or had 5 Ps instead of 4 Ps? That can really be that piece of bringing in the culture and your values into your seed saving. And then to really make choices about buying locally adapted seeds. Like for us down here, we have Siskiyou seeds and Territorial there in Cottage Grove, Hardy seeds. And this is my friend Keisha down there from Farrell Farm Seeds. This is her work, cultivating mustard seed for her community, mustards to feed her community. This is not a lab environment where genes of fish and pigs are being spliced. This is a place where the plants are learning how to grow in our Oregon soils, our Oregon climate, our Oregon environment. And she's a person who breaks her back in this work and is worth supporting. There's also the Agrarian Sharing Network, which is so cool, which they have these amazing events around the state, and that they take cuttings from trees and plants and really encourage this ethic and culture of sharing the abundance that we have with each other. And they are a really great model for that. And to attend seed swaps, to, if I know that your local seed swap there maybe is coming up, if maybe somebody might put in the chat about when the local seed swap is happening for you, but down here in Southern Oregon, we have several, and that's important community building. And I feel like a lot can be learned, and that's where you can find those locally adapted heirloom seeds from people that have a story or a relationship with it. And it's really bringing the culture of your region to connect in that way. It's really special. So I love this quote. I'm going to read it to you. Everywhere I looked, I saw how seeds were holding the world together. They planted forests and covered meadows with wildflowers, sprouted in the cracks of sidewalks, or lay dormant until the long-awaited moment came, signaled by fire or rain or warmth. They filled the produce aisle at grocery stores. Seed breathed and spoke a language all their own. Each one was a miniature time capsule, capturing years of stories in its tender flesh. How ignorant I felt compared to the brilliance contained in a single seed. Thank you, Diane Wilson and the Seed Keeper, for really bringing our attention to this, that the future really is in our hands, that these are our children and our elders. And we have this opportunity to bring forth this cultural connection around whether it's growing the food that will make that family dish or that cultural, that pumpkin pie or that sweet corn that you love that you share with your family, but then begins that sense of valuing. So if y'all want to geek out more about this, there's my email, and I'd love to be in touch with you. I'd love to teach other classes and help support this information and help people find their way back to seeds. And it really is seeds to the people. You know, that's part of what we're trying to do here. And that's, I feel like, my part of my life's work. And so I just really want to thank the library for hosting this event and for the One Book, One Beaverton being so bold to choose the Seed Keeper and to really bring seeds into our homes and our minds and our hearts this time of year. I see that in the chat, you know, do you have advice for people who don't have land to plant on? Yes, I think growing seeds on your windowsill is a great way to go, and making relationships with community gardens or your neighbors where maybe there is land. But there's also a great program helping connect folks who want to farm with areas that are open for farming. The list of organizations that I recommended, the Friends of Family Farmers and the Southern Oregon Seed Growers Association are two. And I'm happy to send an email with more resources. But I think the most important thing that we can do together, friends, is to really practice what we value, is to really make our dollars, really vote with our dollars and participate in seed saving and planting the seeds that we saved. I see the question, if something's labeled organic, does that mean as well that is non-GMO? That's correct. And that's part of the safety and security of that organic label, is it means that they test to see if there are GMO ingredients, and if there are, it is not allowed. And so that, I really have to say that right now, you know, the organic industry is really under attack, and it's really up to us to help support it and to really say we want seeds, and we want them to be grown in an open environment. Is there an effort to sponsor another statewide ballot measure to address GMO labeling? I really wish there was. And if someone knows if there is, I think that let's get it done, because I think the information is there. We understand enough that we just want to know what's in our food so we can make good decisions. But thank you, friends, for joining me on this evening. I really appreciate your care and intention to read The Seed Keeper, to keep seeds yourself, and to really keep seeds in the conversation about our food and our health and our culture, that we can weave this health and hope together. And so thank you for being part of this class tonight. And thank you, Jeannie, for your help. Really great to see everyone tonight. Thank you so much.